What? I'm here. What do you want? Yo. What a mess, man. Why don't I ever clean up my crap? A. E.
I don't like it over there.
Not somebody.
That's right. Look, you're gonna on.
Give me $20 to do that.
Hi. I'll trade it. I'll trade it. No. I don't want Tyler near Logan. I don't want Logan near Tyler.
So I think the same.
Oh, yeah.
We're ready to use it.
Oh, yeah, I said it's right.
In my own seat.
Why?
Because I'm mine.
You see how it works? But again, you don't know what they are between your hands. We're out there. It is very, I heard everything. And we took the book. I swear.
What?
I can't give you that. And I know this is like getting.
What?
You took the book. I said, I don't care. He said, okay, I've got an extra, you have an extra book, so I'll show you.
That's fine. Yeah, it's not mine anyway, so that's all good.
No, but I.
But you didn't actually want.
It was you guys.
I'll tell them that too. We have to
Yeah, yeah.
all my hopes.
You're not interested in that.
Hello.
We're just saying. Sometimes you have to make a.
I'm gonna talk about
For example, my brother's from Ashton.
Then she has her plans. Taylor says hello. Taylor.
Why would you come with this person?
Taylor enjoys talking to me.
That's weird. That's okay, whatever makes you happy.
Hey, everything. Good job, my name. Hello, Taylor says hi. Taylor says it's cold outside and I don't even know why we're here.
Because it's not.
Taylor wants to know if she should wear this all day.
That's good.
Taylor knows lace. You don't
That's
actually
great. You said it. Don't you dare say that. I never thought of myself doing that. Other people's eyes I can understand, but your own.
I wasn't trying to sign my own. I was trying to figure out what was.
So you're gonna tell that by looking at the light? Or-
Yeah, I was trying to figure out exactly.
That don't make no sense.
Taylor confirmed it.
I know, I think so.
Taylor says that I'm not prepared for that. As
Oh,
for,
yeah.
yeah, I don't think that's what they're doing.
You won't be the only one.
Yeah, that's what I'm saying. Pretty sad.
You are. Did you taste anything this weekend? Did you taste your pillow in your sleep?
Taylor says that where there are
Let's say this.
That's good.
It'd be bad time this week.
Sometimes.
Last 3 years. Yeah, we are.
Yes, the water comes on.
Rock.
No, it's not.
What? No, you can't rock.
Taylor says that your name is Brock, mine are Broccoli.
Elaine. Elaine.
Where's that lady? Popping in.
Nick, we got food.
Taylor, who has food?
Where's she at?
Taylor loves food.
Are you serious? Come on.
Taylor.
Why is she crazy? Bye, Taylor.
Everybody wants to see it. There's only 2 schools that
Oh, it's crap.
my only customer.
Do you have a?
Yes,
I got that. I know I said that. Okay, we smell their seed.
Serious on me. Oh, yeah, that's right, Mom. Because I was doing my church. I'm just really sitting on the. I'm just really sitting on. Well, I'll be very, very. You sit right there. I'll sit on the. No, this is where I'll be. You not,
No, really.
Say,
Is it one
no,
of
he
the-
hit me with a chair. You fell. You fall, I hit you with a chair? Well, yeah. Okay, then I put a chair down. Oh, no, break the chair. Golly, it's hot.
Good morning, Cougar Nation. A beautiful, wintry day on the hill as we take a moment of silence. Please stand for the pledge.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Thanks, Abby, for helping us with the pledge. Today, we are in Mr. Jones' English 4 honor.
Why is it doing like that? It's supposed to be.
Hey, Julia, tell us, what are we learning?
It's a bush, not a tree.
Analyze literature from a historical perspective and learn to write in a variety of modes.
We appreciate that. Thank you. Cougars Helping Cougars will work on painting the English department book room tonight until 6 p.m. Please make sure your ride is on time. Congratulations to the members of the forensics team who won awards at the Brentwood Academy tournament this past Saturday. Alex Gooch placed 5th in storytelling. Tucker Spicer placed 4th in impromptu speaking. And Alyssa Carter placed 2nd in prose interpretation. Any student who wants to help with DCHS tournament this Saturday should sign up in room 107. Tennessee Achieves will visit Dixon County High School in the Connolly Auditorium on Thursday, November 20th at 9:45 a.m. to deliver Tennessee Promise handbooks and have a brief 15-minute assembly with the applicants from our high school. The assembly will introduce the Tennessee Promise Scholarship, the Tennessee Achieves program, and the requirements the students must meet in order to remain eligible for the Tennessee Promise Scholarship. They also discussed the 2 mandatory team meeting dates and stressed the importance of attendance in regards to scholarship eligibility. Remind to retake pictures. They're in the front office. Please pick them up. interested in applying for the Hugh O'Brien Leadership Seminar should stop by the counseling department, pick up an application. This seminar is designed to empower high school sophomores to recognize their leadership talents and apply them to become effective leaders in their school and community. One DCHS sophomore will be nominated. Deadline to apply is November 26th. See Ms. Allison for more information. HOSA will sponsor the annual Red Cross Blood Drive on this Friday, November 21st. HOSA members will be signing up any student that would like to donate blood during lunch this week. Spanish Club members will have a first Spanish fiesta after school this coming December 1st. They'll meet at Mazatlan at 4 p.m. Place your order for Spanish Club t-shirts. Shirts cost $18. Money is due this coming Friday. Make checks payable to Dixon County High School. Give money orders to Ms. Gooch, room 211, or Ms. Thornton, room 212. Food for thought. Today, if you have integrity, nothing else matters. If you don't have integrity, nothing else matters. Alan Simpson, former U.S. Senator. Have a great day, Cougar.
Hi. What is that? We're doing okay?
No.
How
do I get it where I don't have zero? The only assignment you had.
You gotta turn it in.
What is it?
The, subwork.
What was it?
It was chapter 6. I'll put on board, okay? I think a lot, actually, more than half the class hasn't done it.
For whoever has the
Whoa.
rolling computer lab number 1, could you call the library immediately, please? 25019. Thank you.
Not me, not it. All right, so the makeup work for the sub work is actually just the sub work. So it's chapter 6, definitions for the whole chapter. And then do the section questions for section 3, 1 through 7, and section 4, 1 through 7. If you want to take a book home with you and get it done, that's fine, you can do that. Yes, sir.
So, is that under account?
I haven't put that in yet, yeah, I'm just keep it in mind, I'll get it. What's up?
Why did you decide to be a teacher?
Well, I was gonna be an international businessman, because I know Chinese, and that would be, I could make $300,000 a year doing that.
Can you say something in Chinese for us?
No, let's not say that. Let's say,你的妈妈很漂亮.
What?
Said your mother is beautiful.
Oh.
You don't know
I don't have to know her to know she's beautiful. I mean, you're not ugly, so she has to be
I'm
something.
adopted.
I mean, she could have beat you, so.
What?
Yeah, really.
Your mother seems like a nice lady.
Anyway, so I was gonna do business in China, but I realized I don't like to travel.
What?
Yeah.
You went to travel?
Well, back then I didn't. When I was in college, I hated traveling. I just wanted to stay home and hang out. And so I was actually a camp counselor for youth camp a couple years, and loved working with the young people. And I've always loved science, especially when I was older, and thought I'd put the two together, and it's working out pretty good.
How much? Say you could have made?
Probably 300,000 if I was good at my job. Why
don't you do it?
I don't like to travel, man. If you're not happy doing what you do, the money don't matter. I mean, I'm not even making a fourth of that. Making a sixth of it, I guess. That's all right. I'm happy. I get to hang out with y'all all day, make jokes, stupid voices, stupid faces, do things in your ear, make my hand fart in your ear. I suppose we should do something, huh?
No.
If we don't get you occupied, you guys get nuts and do weird things.
Why don't we just sit here and play
I'm
games?
too tired to do anything.
That's okay, you can just sit there. And do a little bit of writing too. All right, so I'm gonna take a gamble on this video I found. We're gonna watch it after we finish the notes, but it shouldn't take too long. I didn't get all the tests graded like I had intended to this weekend. I lost the tests for about 6 hours. But when I found them, I didn't have time to grade them because I was doing other stuff. And I stayed up entirely too late last night, even though I knew we'd have school. But, so I'll get the test done
We're
today.
getting out soon.
Was that?
We're getting out soon. Not today.
Well, we are getting out today.
Yeah, they'll start.
More snow's coming.
Wait, we're getting out
I'll
today?
let you know that.
When?
Oh,
3 o'clock.
Oh, shit. God.
See, you knew what was coming because I done it before.
Yeah.
Yeah, you learn to expect things.
That's what makes sleep.
Anyway, so I'll get the test done tonight. So far, the other classes look really, really bad. There are several students who've gotten 100% and also a little bit higher because of bonus points. 2 of the questions I decided to make extra credit because I realized the wording of the question wasn't enough.
On what, South State Track?
No, I haven't. I'm still working on that. I've sorted a bunch of the stuff, but I haven't looked at the level of participation yet, so.
Oh, okay.
I'll be putting it on.
I answered all the questions.
You did? I did see that. All right, so if you would, please get out your notes. And I'm gonna give you guys a minute to review. We'll do a verbal quiz on what we covered, and then we'll move on. So pay attention to original horizontality. Super. Oh. Does anybody know what sublimation is?
That's like sweat.
What is it?
No?
Changes from like water directly to like, it changes like to a solid directly to a gas.
Yes, sublimation, changing directly from a solid to a gas. If you drove to school this morning and there was frost on your windshield or snow, and it didn't turn to water, but it disappeared, that means it turned straight into a gas. And that's why if you don't use your ice cubes in your fridge, that's why they shrink after a couple of weeks or months or however long you don't use them. So if you pull out your ice cubes and they're smaller than the tray, that's why it's sublimation. Sublimation is my favorite English word.
Because it is sublime.
Just fun to say, sublimation. Makes your lips and mouth flow comfortably. Okay, so superposition. What else we got? Uniformitarianism.
That's my favorite English word.
Uniform.
I don't know. But it's cool.
Strata.
Arnold.
What else we got?
Stripe,
Got it. Oh yeah.
orange,
We'll do. We'll also do.
C4 spread.
Yeah, C4 spreading, but erosion rate. What does that mean, erosion rate?
That's like per year, that's what I'm saying.
Yeah, how much it does it erode, and then C4 spreading rate.
At first I thought you said C4 spreading rate.
That would have gotten your attention. C4 spread rate.
When in doubt, load up.
C spread rate. And then I think that's it for now. All right. So review that for a moment while I finish getting everything booted up. And be rolling. I have a weird question. I would imagine. And that's perfect. So you should have out your notes unless you're gonna use your device, and then to save time, do you have AA batteries extra?
I do it myself.
That's all right. I just need to go buy some.
I try to get lucky,
You guys get cold, you can go in the closet, it's nice and warm in there. And then when you're warm enough, you can come out and say, look, I just came out of the closet.
I had to do that at the day, at the college trip, because I pushed me to the closet.
Yeah, I come out of the closet at least once a day.
Heather, do you have a pencil on borrow?
I do not.
One right there, I got your monitor.
Say what?
There's a window that's right there in your monitor.
Oh, there is. Hey, and I do have something else too. I bought some eraser caps.
That's good.
For our use storage storage.
Hey, can I come up there and take pictures?
You?
Take pictures.
Oh, yeah. Why don't you just bring up a chair right here or something? I think it's equal. Anybody else need a eraser cap? No? Oh, yeah. If you're gonna use your device, come put your name on the paper.
Let's see it then. All right. Do you have a pencil?
Anybody need some lead? I've got a 0.5 piece right here. I think it's 0.5.
You mean you just walk around there every time?
You can't get it from, oh, you're taking up the street? My bad, I forgot. Yeah, let me look at this.
Bring that.
What? Thank you.
You're welcome.
I counted up the numbers. We had 123 students participate in Sci-Stu Chat on Thursday. A lot of them were my students, of course, but we only had, yeah, I think we only had 12, no? I think we had 12 scientists participate. Usually we have a lot more. I'm not sure why we had so few, but it's all right. Okay, so devices down, notes covered up for just a second while we do the verbal quiz. All right. Peyton, tell me about original horizontality.
Original horizontality?
Yeah. Okay, so you guys can look at your notes while he's thinking, okay? Because if you don't know it and I call on you next, you're gonna feel silly because you had a chance to look it up. Hey, you're not supposed to look into this.
Oh. Never get look.
No, I said that.
Oh. I know it has to do with layers.
It does have to do with layers.
That's all I saw.
Okay, so we'll try someone else, so everybody needs to not be looking now, Ashley.
All the layers of rock start out horizontal.
Layers of rock start out horizontal, very good. So Peyton, what is it?
All the layers.
And what is that?
Wow, horizontality.
Originally horizontal, right?
Yeah.
Good job. Okay, Maribel, tell me about superposition.
The layers on the bottom of the water.
Yeah, layers on the bottom of the oldest. Let's see, Erica, tell me about uniformitarianism.
Laws of nature don't change.
Good. Tyler, tell me about strata. Tyler, sorry. Strata.
The layers.
That's superposition, but it is layering, right? Good. Tate, tell me about the rate of erosion.
The speed of how much water erodes rock in millions of years,
Okay. And what's the average speed for that? Hey,
about 5 or 6 minutes.
no. 3 to 5 millimeters. That's cheating, chicken heads. Okay, good. So let me try one more. Austin Newberry, tell me about superposition again.
Layers.
Yeah, it's missing a wheel, so you may want to be aware of that. If you want to switch your chair, you can.
How is layers on the bottom?
Good. All right, let's get flying. Chop. Okay. Okay. Superposition, strata, layers, pictures.
You got that one.
Sweet. How is the Earth based on evidence in the Grand Canyon?
Probably 6 million.
And how, because of those layers, because of the erosion rate?
4.5.
No, 5 to 6 million years. Okay. When we look at the evidence of the Grand Canyon, because of how long it takes for everything to erode, it's 5 to 6 million years. All right. So then we talked about the shape of the planet or the continents, and that they used to all line up together like a big puzzle. And I didn't show you this, so let me show you this now. Oh, it's already playing.
Wegener was browsing through some books when something caught his eye. A list of identical plant and animal fossils that had been found on opposite sides of the Atlantic Ocean. Wegener was intrigued. How could the same species have gotten from one part of the world to another? He examined the eastern coast of South America and the western coast of Africa and was struck how the shapes of the two coastlines might fit together. The more he looked, the more links he found. Species of land mammals in East Africa also inhabited the island of Madagascar. How did that happen? Did the animals evolve in both places at once? Or did they somehow cross from one land to the other, swimming hundreds of miles across the Indian Ocean? And then Wegener saw it all clearly. He realized that all the continents in the world had once formed a giant single landmass that he called Pangaea, from the Greek Pangaia, meaning all earth. It was in Pangaea that the plants and animals found on opposite sides of the world had once shared the same home. Then, over hundreds of millions of years, Pangaea had split apart, and its jigsaw pieces had drifted to their present locations. Wegener called his theory continental drift. Wegener wasn't the first scientist to speculate that the Earth had once been dominated by a supercontinent, but he was the first to pull together all the evidence and make a strong case for it. Unfortunately, his peers weren't very receptive. There was no mechanism to explain how the continents might plow through the oceans. To speculate that the Earth had once been dominated by a supercontinent, but he was the first to pull together all the evidence and make a strong case for it.
So, and I know we saw this in the other picture, but that's a pretty amazing fit. And so what we can do is we can measure the distance and divide by the seafloor spreading rate.
Fortunately, his peers weren't very receptive.
And you guys remember what the distance was or what the rate is?
1 to 3.
Yeah, 1 to 3 centimeters. About this, the length of time it takes for your fingernails to grow in a year.
There was no mechanism to
Okay, so then we talked about magnetic pole flip, where sometimes the poles flip directions. The Earth stays the same, but there's a magnet, let's say the pin is a magnet inside the Earth. Once in a while, that magnet will flip. So north will be south and south will be north. The Earth stays the same, okay? It keeps going around like it normally does, but the magnetic pole will flip, okay? I don't know why that is, but it happens, and it happens about every, well, between 100,000 and a million years, somewhere in there. In fact, it's been 750,000 years since the last one. So in some regards, we're overdue if we're going on average. So 750,000 years since the last one. And you can see the reason we know this happens is because when the seafloor spreads, new magma comes up, right? That magma has iron in it. And the iron is magnetic. So because it's magnetic, it aligns itself with the magnetic field. So the iron filings will be pointing north when the magnetic north is north, and iron filings will be pointing south when the magnetic north is south. So when that flips, they can measure it out. In fact, show this one. They can measure the distance, and they'll go, when they go out to a certain point, they have a mirror image of when the magma came out. So this one would be north, south, north, south, north, south, and they can measure that with a compass when they go along the bottom of the seafloor, showing the spread it takes. So when they do the math for rate of spreading, and when they check out these layers, they get about 200 million years. So we've gone from using 10,000 years to looking at erosion rates for 6 million years, and now when we look at seafloor spreading and continental drift, we have a number that's 200 million years old for the age of the Earth. Is there other ways to tell? No, we can go back further still. With radioactive decay. Okay, so on somewhere I want you to write down, what is radioactive decay? What do you think radioactive decay is? Okay, talk about it with your neighbor for a second. See what you guys think. Do you have a common answer? So Devin, this is Chris. Chris, this is Logan. Chase, this is and Dave. I don't know why I just skipped on your name. Sorry about that. Are you? Can there's something there? Hi. Talk. What is radioactive decay? What do you mean? What's radioactive decay? That's radioactive. What'd she say? What's radioactive? Okay. What'd you tell her? Yeah, you guys talk. Did all you guys stay up too late thinking there's going to be a snow day?
I did my snow days.
Did you wear your pajamas inside out? All right, who thinks they have an answer for what radioactive decay is?
Ashley does. Yes, I get it. I got it.
Ashley, they say Ashley has an answer, so let's see what you got.
It's the breakdown of nuclei.
The breakdown of nuclei. Nuclei of what? A cell? A cell?
I remember, we studied this last year.
Okay. It is the breakdown of radioactive nuclei, but it's not of a cell, it's of an atom. It can give you cancer because those nuclei, when they break down, they go shooting everywhere and they rip up your DNA and your cells and whatnot, and it causes problems. So radioactive decay, basically this is what we're defining here. So half-life. Radioactive decay is defined by the half-life of an object. Okay, half-life is how long it takes for half of something to disappear or change. Okay, so I have a plate here, and actually it'd be better if I use a sheet of paper. Oh, thank you, I appreciate it. So I have a sheet of paper here, and we'll say this paper has a half-life of 20 seconds. Okay, so because of radioactive decay, after 20 seconds, half the paper is gone. Okay? So what happens after 20 more seconds? The other half will be gone? No. Half of the half will be gone. How much is that? Quarter. Okay? 20 more seconds, what happens? Another half is gone. Okay? So now we have an 8. 20 more seconds. We have a 16. 20 more seconds. 30 seconds. 64. 128. 256. 512. And so on. Okay? So what happens is that these elements, they change into other elements when they decay. They don't actually disappear, but they change. All right? So let's say that, well, probably should just move to the next part. Well, yeah, this is the door. Okay, so we'll just say distance to, we'll go from the door to my desk. Okay? If, what?
Can I use the restroom?
Yeah, please do. Go pull in. I'm gonna walk to my desk there, and we're gonna say that the half-life is 2 seconds. How far am I gonna get in 2 seconds? Halfway. Okay, so 1 1,000, 2 1,000. Okay, how much farther I'm gonna get in 2 seconds? Okay, talk to your neighbors and discuss. 2 more seconds. Where am I gonna be? Okay, seriously, talk.
Take my kind of stuff.
Just gonna be on the corner of the desk.
You guys agree?
Yep.
Okay. All right, Gabe, where am I gonna be? Okay. Let's do Greg, where am I gonna be? Okay, Tyler, where am I gonna be? Jason, where am I gonna be?
I think halfway from where you are to the. I think so.
You said you agreed with him.
I changed a lot. I had a headache.
It's gone now?
Yeah.
Oh, that's good. Okay, so am I gonna be at the desk or am I gonna be halfway to the desk?
I think so. I say halfway.
There'll be a foot from the desk.
You guys remember what happened to the paper? If I'm to the desk, you're saying the paper would already be all the way gone after 20 seconds, right? How much was left after 20 more seconds? Half. Okay, so after 2 seconds, where am I gonna be?
Halfway to the desk.
Greg?
He's gonna be at the
32 seconds. to get
They're gonna
there.
be back at the door.
32 seconds to get there.
Because it's half. It's half of whatever's left. That was an awesome question.
So it'll be halfway to your desk.
Again, that's right. So Gabe, where am I gonna be in 2 seconds? Okay, to the phone, good. So after 2 more seconds, 1, 2, I'm here.
What kind of, that was. You gotta do that again.
Fine. 1 1,000, 2.
Okay.
Okay, much better
You
now.
went one,
Okay.
two,
Where am I at? Halfway or all the way there?
you're flat, we're all there.
I'm half of where I just was, but I'm 3/4 of the total distance, right?
You never actually get to your desk. You just keep having.
Yeah.
He was half all the way there.
Jason makes a good point. You never actually get all the way there because you're always going half of what's left. Now, yes, I'm going to be so close that I can touch it. But if you start splitting atoms and quarks and everything and keep making it shorter, then you never actually make it there. Okay, so
Radioactive dating is how we date things, how we figure out how they are based on what atoms are left. Because there's special kind of atoms that don't rot. That rot into different things. So over time, radioactive elements can decay to form different elements. That could be an important thing right there. I see a lot more people on their devices than signed up over here. So hopefully you'll have evidence and you take notes on your device for all. I'll be enjoying your device and phone jail next time. So it takes 1 second. All right, so an example of this is uranium-238. Uranium splits its atoms, like Ashley said, and becomes lead-206. The time it takes for half of that to happen is 4.5 billion years. We haven't been here that long. How the heck are you going to know? Anybody? How would we know that if we haven't been here that long? No one's been around that long to make that, to see that happen.
Technology showed us.
Well, that's one way, yeah. We can measure how fast uranium decays right now and project or make a prediction about how long it would take for half of it to decay. And we can measure levels of uranium and other things right now as well. Okay, so uranium-238 rots and becomes lead-206. That has a half-life of 4.5 billion years. Okay, now I know you can't see this very well, so let me zoom in on that. There's a few numbers here you're going to need. You need the uranium number. You need to know what uranium becomes. Okay, so uranium-238 becomes lead-206, 4.5 billion years. Make sure you have that down. And then we're going to have we'll have one more number for you. There's man-made elements that take less than a second for their half-life to go. Basically, after a minute, they're completely gone almost. Okay, so uranium-238 becomes lead-206.
What's the difference
And the uranium's here. Yeah, those are uranium isotopes. And uranium, I think, has the atomic number of 92.
Oh, no, never mind.
Yeah, 93 is Neptunium.
Yeah.
That's cool. Neptunium. So uranium has a half-life, or excuse me, uranium's atomic number is 92. So U92. So that means that in its nucleus there are 92 protons and typically 92 neutrons. If you add those two together, you get 184, right? But this number right here tells you the number of protons and neutrons. So if uranium has 92 protons,
You have to have more neutrons and protons.
yeah, so 238, what's 238 subtract 92?
100.
156.
Sure.
6.
Okay, we'll say 166. So that's the number of neutrons. So this means this has more neutrons than this uranium. It's got 3 more than this one. And that's an isotope. Isotope has different number of neutrons than those protons. And I'll give you more detail on that later and make it easier to understand. So that was a little confusing. All right, the other number you need here, so you have uranium-238. The other number you need is carbon-14. Okay, carbon-14, this should actually say nitrogen, not hydrogen.
Nitrogen, carbon,
Mm-hmm. Yeah, so carbon dating is using carbon-14. So carbon-14 turns into nitrogen-14, and that has a half-life of 5,730 years.
It should turn into hydrogen.
Uranium half-life, 238 is 4.5 billion years. Carbon half-life is 5,730 years. All right, so the reason this matters is because we can use these different dating methods to determine the age of objects, rocks, skulls, whatever. Because we have a range of different atoms we can use to measure, we can determine how old things are. Carbon-14 is not going to be a good dating tool for dating rocks, because rocks are pretty old. And once you get your levels down so low, it's hard to tell how old it is. So if I found an object that was 11,000 years old, how many times does that object decay? If you're using carbon-14. Basically twice. It's gone through 2 half-lives. Okay? And we'll have some practice with that here. All right, the last little bit we have is unconformities. So radiometric dating is the best way to determine the age of the Earth. And when we look at the rocks, we discover, and look at the uranium in the rocks, we get an age of about 4.5 billion years. So that tells us the age of the planet. So we went from 10,000 to 6 million to 200 million. Now we're at 4.5 billion. Let's see. Yeah, so unconformities, you just write down unconformities, and that just means messed up in the strata. This is another picture I took when I was in Utah. This is not far from where I used to live when I lived there. But you can kind of see how the rock layer comes up and then goes back down. Okay? Unconformity means when there's been a problem in the rock layers, that there's been some sort of earthquake or spreading or erosion and then more layering on top.
Look how hard it's moving.
I know, it's crazy.
It's small.
It almost might pile up to 4 meters. So here's a better shot of the same rock formation. Now, these things don't happen overnight. Okay, earthquakes, when there's an earthquake, it doesn't end up in something this big. This would take millions of years to make because it moves very, very slowly when those changes happen. Was that? Oh, yeah? And then you woke up? All right, so but that was more of just interest sake than anything else. So let's show you the video.
It's today. Do we have regular CP?
I think so. This video should help explain things a little better. I'm just keeping my fingers crossed because I haven't heard the whole thing, but I have watched it. That makes any sense. Oh, that's exciting.
Life on Earth is a mystery that biologists and geologists have been trying to The history of life on Earth is a mystery that biologists and geologists have been trying to unravel for hundreds of years. The most important clues to this mystery are fossils. In order to understand how organisms evolved through time, we have to know when their fossils formed. Fossils form when organisms are buried in sand and mud. As layers of deposits build up, older sediments are compressed into rock. The organisms form fossils within.
So if this fossil is always found in this layer, and I go somewhere else on the planet and I find this fossil, do I need to date that layer? No, because I already know the age of that layer because it's the same fossil. Okay, and then they can do that.
The rock. The younger the rock, the higher it is in the rock layers.
What's that called?
Superposition.
Superposition. Yeah, the higher it is, the younger it is, the lower it is, the older it is.
The fossils within the rock layer are the same age as the rock itself. In studying the Earth, scientists discovered that similar fossils appeared in a consistent way through the layers or strata of rock in different locations around the world. These fossils acted as an index to the time the sediments of the rock were deposited. Comparisons could be made between buried rocks based on the fossils within it. In this way, scientists were able to develop.
What's that?
Why did they move the middle column up?
Because of the fossils. In different parts of the world, different layers will have been affected in different ways from earthquakes and erosion. So you're going to have the layers in different position, but they're still the same
A
age.
geological timescale. Important events in the history of life, like mass extinctions, were apparent from the disappearance of fossils at a consistent layer in rocks around the world. With a relative timescale, biologists knew the order in which fossil organisms appeared, but no one could be sure about the precise ages of the fossils. Calculating the absolute ages of fossils was impossible until radioactivity was understood. The gradual breakdown of a radioactive substance in rocks is the clock that scientists use to measure geological time. In the process of emitting radiation, radioactive isotopes decay into different isotopes, eventually producing elements that aren't radioactive. For example, the radioactive isotope uranium-238 decays into the stable isotope lead-206.
How long does that take? Uranium to lead?
4.5 billion years.
Each radioactive isotope decays at a unique constant rate, described by its half-life. The half-life is the time it takes for half of a given quantity of a radioactive isotope to decay into another isotope. The half-life of uranium-238 is 4.5 billion years. That means it takes 4.5 billion years for half of a sample of this isotope to decay away. Consider a rock containing uranium-238 that formed at the time of the earliest known fossils, about 3.5 billion years ago. Today, it would contain 58% of the original quantity of uranium-238. An isotope with a shorter half-life would be better for calculating the age of a younger rock. It takes millions of years for a significant amount of uranium-238 to decay from its starting level. An isotope with a shorter half-life would decay more significantly in a shorter time. The greater change in the amount of isotope would allow a more accurate measurement of the age of a younger rock. Radiometric dating is the method of determining the ages of rocks and fossils using radioactive isotopes. Using sensitive equipment and great care, scientists measure the amounts of a radioactive isotope and its decay products in a sample of rock or fossil in order to calculate its age. With the help of radiometric dating, the relative ages of rock strata and their fossils have been converted to absolute ages.
And she said, oh, never mind.
And our picture of the history of organisms evolving on Earth has become increasingly clear and consistent.
That's it. Clear as mud, right? Always. Okay, so just remember that things have half-life. And we'll go from that. We'll go with that tomorrow. Okay, any questions? All right, so I need evidence of Notes use from Austin, Brock, Devin, Tyler, Elena, Greg, Christian, Chase, Jason, and Hunter.
Those movies make me mad. Those videos.
Oh, yeah. Why?
Because it looks like kindergarten. The video goes like, we can learn something.
All right, well, I want to go then. Oh, yes, anybody else have their permission slips?
For what?
For, the survey? I don't know.
Is it out of the school?
Yeah. All right. All right, I still need to do the prize drawing, but also everybody who, did the, yeah, okay. Everybody who turned in the survey will get an ice cream from that cafeteria, and I'll get those copies.
Ice cream sucks. Not the Snickers. I know.
What?
Yeah, I know.
Like, they give me little.
I know, I have to delete it. I'm like, it said, I looked at y'all and it said, I was like, there's no way we're not.
Hey, you saw my son's teeth on Instagram.
What?
My son pulled out 2 teeth within 15 minutes.
Wow.
His own?
Yeah.
Your son's awesome.
Yeah, it's pretty cool.
So you gonna put him around his neck?
David Bates. 25.
Yes. May I run down to? Yes. I did a wanted post here. Choose an easy party.
Yeah, go ahead.
We're just reading. I was thinking about doing it on Abigail and saying like she ran or whatever, but they said she had to be accused of what.
Yeah, that's all. So everybody's
She was wanted,
I guess she was wanted after.
What's the other one I need to call?
Randy Powers.
Howard.
I'll see y'all later.
No, it's in your pocket. What? How much put in your pocket?
I'll put them in my jacket.
Mr. Randy? Hey, this is Adam Taylor, in 115. If you guys aren't doing anything during CP, can we see Tyler Willis for a second in, room 115? Yes, sir. Thank you. Okay, I need some help with the snake.
I guess my locker gets that. I guess my locker.
What? Jesse, what? Where you guys?
Then I'm break out my ice skates and go skate on the road.
You're nuts.
Oh, ice skate school.
Yes.
Ice skating is very fun. I started ice skating when I was 3 years old.
Yes, sir. Yes, sir. Hey, come put your name. Huh?
Is this the book? Is this the word?
Yes, sir. Come put your name down and the number of the book.
No, yes, it stinks. If he's still in school, we need to turn them back. Yes.
Taylor,
Hello. No, he went to CP, I think. I don't have a printer.
What was that?
Next week. Get out the scheme of that filing case, that'd be great. We're gonna do. Just up a note and all.
You have a little thing.
I just get a quarter of this paper. All right, good luck.
Mr. Taylor,
Yes.
is Owen Hunt still in class?
No, wait, Owen?
Yes, sir.
Yeah, he went to CP.
Where was he going, do you know?
I don't remember.
Okay, so they don't sign out?
I had a list, but I don't remember where I put it, because they all go to the same place. Anybody know where Owen goes?
Doesn't he go across the hall?
I think he does go across the hall. Let me go check. What's your extension? 20? Oh, okay. Thank you.
Did we dump the water out? Oh, where'd it go? Yes. Whoops.
I've been watching that in water for a long time, but it kept laying
Oh, here? Tail shop.
Hey, can anybody text him? Text Owen and tell him.
You can change the water out?
Yeah, that'd be great. Just go dump it outside.
He wasn't in there?
No. Can you text him, tell him his mom called in the office, he needs to go to the office?
Oh, and his mom was next to him?
I don't know, she may have tried. Pull it all the way. Thank you, sir.
Wouldn't that be able to look his name up on the computer and maybe be able to know where he is?
No, because I don't think they put CP into the computer.
What's his first grade?
What's that?
What's his first grade?
Here? Yeah. Did somebody text him?
I don't have his number.
No one has his number? Ooh. So he has no friends? Sad. It's kind of like me. Every night I dream of having friends. When you guys aren't looking, I pretend you're my friend. Well, why would I need friends when I have the internet?
And mine, yeah, mine. How you spend your time, just going through.
That's right. Jeremy, do you have Owen's number? Owen Huff?
Do you mean to get every little piece of skin out?
Just, as much as not, just so it's not too much of a pain, that's fine. Whatever works.
So you can have how much it's just for that. Every single time.
Do we need to do the other snakes?
I don't think they have sheds that are laying around.
Did you ever get Chinese sea water?
Yeah.
Hey, did you do a stuff project?
No crap.
Is it due today? Yes.
Wow.
I don't know what to do. But I think.
There you go.
She keeps your 94-year-old. She's 90.
You should stop asking.
No. I figured out a solution. I'll send it out on Sully. Here, hold on, let me get you a note. This is probably won't.
Probably somebody has.
How do I do the rest of your work?
He'll be like, can I get a look? She doesn't know.
I was proud of that. I had it was very cold. It's my game. We had it Friday night. Now. Find out if it's still good or not. Crack one and give me the crack one. Huh? Crack one and give me the crack one. Why not? It's all over. You came on. Oh, I didn't. can handle a bit of truth. Oh, they're not like them. They're done.
A little bit.
And they're very. You don't know if it's on there. I don't think you get there.
You guys can have fun cracking. That's what's cool about fun things.
Put it in the microwave.
Put you in the microwave.
Oh, half if they go to lunch, like,
It'll let it go.
That, if you put them in there for 2 hours, so you just gotta get.
Hey, Morgan!
You just gotta get them away.
I remember when someone in my family, I come out of my bedroom, I come to the kitchen, and the cat.
Are there really 6 kids in your family?
Huh?
Are there really 6 kids in your family?
No, there's none.
From the same mama?
Yeah.
Holy crap, that's awesome.
Not really.
She would have had 10, but
Well, I wanted to have 9. My wife wanted to have 9 when we first got married.
Wow.
that's been going
And then,
on.
You got one.
and then she had, no, I got 3. And then we had 3, and she's like, I'm done. I'm like, okay. Because the last one was sold herself. We figured we'll probably stop. Hey, this one works too.
Are you just giving them out now?
Yeah, if you want one. Hey, man, I'm sorry, I shouldn't call you man. I was embarrassed. Call me man. Man? Man.
I'm a man.
You're loving it.
Do that, boys.
Ready to take? Monday, did you bring those?
She's got clothes on, what are you talking about?
Yeah, Lloyd, where's your teeth clothes?
It's the friend code.
I don't know if I'm comfortable with
like
this.
Which one was it? This one like that.
Well, we had this conversation every week.
I did bring clothes.
Alright,
Walker.
Taylor, you where's your movies?
There's one, it doesn't have my.
Where are my movies?
What are you gonna do? We don't want to go to. With 10 cents, with 10 cents is.
Yeah.
With 10 cents is. Paragraph.
That's a.
Right here.
Here.
As
a.
It's supposed to be a sentence. Paragraph. It's not supposed to be.
Yes, you will.
Bullets.
I don't think, I wish you would. I don't think she did, I don't care. But. No, you're not here, you know, stuff. You know, stay with.
Oh, that's safe. Bring in blue, you can get out of it.
Oh I like them bigger.
Still don't know.
Yes, we
Hey, if anybody needs binders, you got a whole bunch of binders.
Oh.
We're starting next week.
You're on just.
I'm actually.
There's even more of the zipper.
I guess.
They may have been here for 20 years, I don't know.
Any of the composition with
Glue.
what year?
I did.
But they got their, username and password. Okay, that's good.
I know I did, after all. I just don't know what it is.
Hey, you can do it. That's your decisions. Willis. Should be awesome.
Hey, yeah.
Is there any more? Or longer?
Deal with your decision, your decision knows.
Yeah.
You're gonna go with like your comfort.
No. And I want my mom to come to the office and get some of this gas. I'm getting hot over there and I'm like, hey. I lived in Jackson for 18 dollars, but they said I had to take you to go in there. And I'm getting all kinds of pictures this year.
So you just
So
say
you got it?
the bad stuff. You just like, you
She's mad
don't
at that.
because it's nice one, bro. It's nice
Think it's been hard. You didn't want to know that, I know it did. Don't know what I'm doing. He said the hair was, what we get in my eyes. You're blind, you're dead. Got a big thing going on. Oh, yeah. I could climb up in there and pop that noise. Bring a coffee under the school.
That'd be nice.
That's not nice.
Here, put this paper over.
Have you been with?
Well, I mean, dude, I've been, I can't.
Oh, okay, oh, there's the old paper.
Why are you guys playing with balls all the time? Sorry. I got some, you guys look at it.
You killed the good guy. That was a police officer.
Holy crap. Hey.
I did.
There we go. Mission accomplished.
Thank you, sir. Appreciate that closer with you. Okay. That's not, that's all the food. There's a full rock too.
Yes.
I can't even get it on. I cannot get it on.
How's that work?
It's magnet.
That's awesome. Nice.
Or a mid-row. There's a black guy just killed like 3 cops.
All right.
That's what
I just discovered our.
That's all I know. We're talking
And this looks like a Geo. It's a Geo.
Oh, it's
It's a Geo.
The lights used to work.
Geo.
Red.
I'm getting purple and it's amethyst.
They don't work now.
Oh, dang.
See Geo.
Yeah, I used to.
I never started.
Stop.
What do you read?
Story.
Said story.
I don't
What? Look at the lights in here.
Oh, I don't cry.
That's plastic.
I'm not dressing for you.
Who knows? We'll see.
Very good day. Thank you, baby.
Whatever the one is, I hope it's good.
Brown.
How are you? I know.
Oh, yeah.
Are you all not talking now?
No. No.
Let's do kill hardcore. No.
I told her that we were not getting that together.
Why? Because she
We're
doesn't.
never getting that together. These are the reasons
Did
why.
you see the song for her?
No, I wanted to get the link to send it to her. But I didn't want to be. Did you ever?
That's a weird song. What was, oh, cool. That'll have to do with magnets? Yeah, I heard that first. No, it wasn't, it has to do with magnets. Or I guess they're like maybe two.
For some reason, I get green at the door there today. Okay, how does smell blue sunshine?
Oh, yeah.
I like
Maybe when the sun shines.
We overheard this young boy.
I'll send your lap. Please don't. Please.
You see what?
How is that doing it? How's it doing?
Jessica Grimes to the main office, Jessica Grimes to the main office.
That's not how you learn. You don't
Is that probably?
Okay.
This is metal. No, it's not real. I didn't touch it, so. I didn't.
And then with my career and then, that guy.
Yeah, well, yeah.
Oh, they were not
Why is there so many chairs in here? There's 1, 2, 3, 4, 5, 6 chairs over here. There's only 3 people. There's twice the amount of chairs. Yeah, we're
And so like, actually,
What?
Nowhere to go.
Did you anything after that?
How do you not learn to just hang out everything that's been said?
I had a very low star here with a dominant figure like her, and it had me to hear that PTSD. And so when she treated my PTSD, there's absolutely nothing that I can do. And that is why. What
did you do with the
Hey, I want you to say anything about Christianity, that evolution is a lie.
I'm just saying, I don't see
Well, then you don't understand what evolution
Just to make sure. I know who I would
Whose signature on that?
I have to,
Why did someone come up to me asking me about
Oh. I have to,
Yeah.
number 8. She wants me to be on the television show. So.
Mr. Taylor, how do you have to?
Carlos, I mean, finish notes and stuff. I'm going to finish today.
are we doing anything this coming Friday?
Well, I can't put things get on the internet. They can't put 3
Okay, new seating arrangement. So I realize I'm gonna have to adjust this based on people who have no vision, and I forgot who those people are, so I'll adjust for later. So right here, table 1, we got Brittany, Jeremy, and Andrew.
Last name.
Cooper. Here we got Sarah, Braden, and Jesse. At table 5, we got Hannah, Luke, and Thor. At table 6, we've got Chanela, Caitlin, Scott, and Caleb.
No!
At table 7, we've got Nick, Bonnie, Aaron, and Parker.
Yes! I still got some on the wall. Caleb, are you right there?
Right here.
Some of them have the buttons on though. Sweatpants.
This is weird, I can't see this side of the table. It's like a camouflage.
I didn't see it in camouflage practice.
Late jokes.
2 tickets for seeing dad jokes.
Anybody wants to?
That's the reason I'm a dad. So who's blind and needs a different seat?
I don't know anybody by that name.
Okay.
I am. Oh my God.
I said, I don't know anybody by that name.
Does everybody get a new seat chart?
Yeah.
Or is it just?
Okay.
All right, let's go.
Off camera.
And thus the rate.
Is it just us get a new seat chart or everybody?
We've always had a seating chart.
You're
I've been taught otherwise. Okay.
I'm not skipping. I'm trying.
Oh, everybody's good today. What's up with that?
What's up with that?
I
love Saturday Night Live.
That is a long charging cord.
Yeah.
Good
We got the short one.
grief.
You know why they make them?
My dad's got a 30-foot one too.
So it's great.
If you play on your phone with it on the cord, it messes up the battery.
Yeah,
Yeah, it messes up the whole phone by playing with it on the cord. That's why they're so long, so short.
I want to get some of those no stick headphones. No tangle headphones, man.
Oh, that'd be amazing.
I'm gonna stop getting shoelaces and just lace headphones through my shoes so they'll tie themselves.
So you tickets for sale.
Cheap.
Cheap.
All right, let me
Cheap.
get out your notes from last time. We'll talk about a few things and then we'll get started.
60. Ah.
We can't get no better than
You
that.
love me.
Can't get no better.
60 tickets? Two. One seat.
Go.
One seat.
Country is
11, 12.
Country is insane.
Who are they playing?
Country is the rap of inbred people.
$65. You and your wife can go meet your wife.
Okay,
Buddy,
buddy.
my
My
wife.
trash girlfriend. I can take girlfriend back. My dog ran away. I love my truck and my tractor. Let's go to the road.
Hey, are y'all still playing?
You forgot that.
No, I want to get started.
Oh, beer. My beer.
Yeah, I knew that I really go so long without having it.
Nothing too country. Like, I don't like emo music that much, but like, it's better than country in that.
How do you define emo?
What?
How do you define emo music?
Well, not emo music, emo bands.
Oh.
Like Sleeping with Sirens.
Don't bring that into
They're
this.
so boring.
Don't bring Kelly Quinn's ugly, high-pitched voice here.
All right, Caleb.
You're a buddy. You made it free.
Love you too, Aaron.
Hey,
Caleb, do you have
flash over there.
Concert call.
Caleb, do you have pistol?
Hey, Aaron, I used my thing the other day. My fast stop thing. Did you take it?
Yeah, I get it.
But it wasn't in Dixon, it was in Columbia. That's why.
Hey, I'm in a gang. Do you think I'm gonna get in trouble? Since it's the school-sponsored gang.
Yes.
I'm gonna go.
You guys see my Instagram last night?
I didn't know you had one.
My son pulled out 2 teeth within 15 minutes.
Oh, like literally just.
Well, the roots were completely gone. The roots were completely gone. He's like, hey, Dad, this is loose. Yank.
I did the same thing when I was little.
See, me, I noticed when they're loose, like early on, I'm looking on like a month before they actually come out.
It's natural. All kids do it.
Yeah.
They all learn to do it.
No more.
Okay,
I used to put them under my pillow and get $2.
I bought my kids teeth from him this time, because I wanted to keep them. Because one of them has a cap on it, it's pretty cool looking.
Freaking, I was never getting money when I was a kid, so my teeth.
Do you want these teeth once they have to get pulled off and have crowns put on?
Sure.
Awesome.
They'll let you keep them, yeah.
Do you want my wisdom teeth?
Yeah.
Yes.
Are you serious?
Sweet, I can't wait till I'm 16 and have to get these teeth pulled out.
It's not gross, but I put them on the
You will bury your
I'm
teeth.
sure, yeah, that's why.
Dude, he's gonna come into the school the next year and it's like, I got to fight with 6 students and these are my prizes.
That's right. Okay,
You want to skip to me, son? I'm just kidding in the face.
all right, if you plan to take notes today on your device, you need to come put your name down. If I see you on your device and you didn't put your name down, I will put your name down for you. And then at the end of class, you're required to show me your progress on your notes. And if you're on your phone a lot, but you're only taking pictures, then
Can I see the terms and agreements?
I'm gonna be suspicious of alternative activities. Okay. Okay.
I'm liking the new seat.
Guess what? Georgia won. Told y'all they were early. I'm like,
But it's not gonna hurt us. It's not gonna hurt us. They literally couldn't stop.
There's a little bit of rotate to it back.
yeah.
Oh, the one you were just like.
That was the one that I put there.
This is my thing.
1 and 8. That was 2. A couple of nobodies.
All right, go ahead and review those definitions for a second. We're going to do a verbal quiz momentarily. We're going to establish a position, implementarianism, erosion rate, and I spelled erosion wrong, and C spread rate, C4 spread rate.
Hey, I got all of that. That's what's gonna hurt me.
You can review with your neighbor for a couple minutes.
Besides the erosion rate and C spread rate.
What?
The rate of erosion and the rate of C4 spread rate.
The C spread in the middle because of lavas and stuff pushing it up and pushing the plate tectonics apart. What is erosion? The rate at which stuff erodes. The stuff is, those two definitions are probably.
So I saw a song on the YouTube last night. Yeah.
The rate at which something erodes. The
DJ
rate at which
Swerve.
the C spreads. That's the erosion.
All of them do. You know why they do? You know why the tables have cockroaches in them?
Why?
Because kids cram their food trash down into the inside. So, extra credit for those who point out that others are eating in the class.
Wait, do we get in trouble for eating here now?
No, you always have. I just haven't been very good at enforcing it.
Can I throw something?
We're not ever-
I'm not on my sugar.
Can I throw something? People that are eating?
This is the last.
Hey,
It's okay.
aren't we supposed to get a party again? Like every time?
Yeah, but that's the thing, if they don't.
Every time that we're supposed.
We do good with the.
Remember, we had a sub the other day?
You said whenever we're good with the sub, we get a party.
Oh, yeah, I have to tell the sub, so I don't know who was good.
Okay. That was us, so it's just.
Yeah, she.
Oh, I'm sure it was.
She was.
No, we would.
I think what I'll do from now on is do volume of work completion, like what percentage of students finish the assignments.
Nobody.
Yeah, I'm pretty sure.
There were a few.
I completed it, but that's only because I did it during CP.
Or maybe I'll just have a party for those who completed the assignments.
Yeah. Wait, how you gonna do that?
I will bring lunch or something.
I will bring a snack later. I bring
Cheese, butter, all beer, chips.
Okay.
Oh, God.
I found these are a year old, and they still work a little bit, so if you want one, you can have one in class.
You can have one?
Can
I have one?
Yeah, class.
You just said that like 3 times.
But, and 2 of the times we're answering him. Okay, so let me get out the universe.
Yes, I am.
Name sticks. This has something to do with our lesson today. All right, so now when I call one person's name to answer the question, if you don't know the answer and you were not called, you should be looking it up, okay? Because I may call you next to answer it. Because if they don't know it, then I'm going to try somebody else. And if they say the right answer and you don't know the right answer when I ask you, then that's going to be embarrassing. All right. Caleb, what is superposition? Stop looking.
Oh. That's, the layers of, is it the bottom of the ocean? Is that what it is?
Nope.
Layers of bottom.
You guys can't help it.
I can help you now?
No, because I'm a full another step. Caitlin, what is superposition? There's on the bottom of the oldest. Very good.
She's so right. Look there.
All right, so I'm going to come back to Caleb and ask him again in a minute. Jesse, what is uniformitarianism?
What is this?
We'll talk about that in a minute. What about it? Okay. Come back.
Great.
Jeremy.
What?
Where do you go? Uniformitarianism.
That's thing about the laws of nature don't change over time.
Very good. Laws of nature don't change over time. All right. Brayden. What is? You gonna answer without the question?
No.
What is original horizontality? Okay. You're being honest. That's good. We'll come back to you. Let's see.
Right.
Andrew Hooper. Oh, you weren't here that day. Huh? No, it wasn't. Hannah.
Oh, yeah.
What is original horizontality?
Original horizontality is where like layers are horizontal and they like start and they just keep going up.
Okay, good. Sarah, what is strata?
The layers.
Good. Luke, what is the erosion rate?
The rate at which
Don't
these erode?
Yeah. Do you remember the number?
No.
The average number? Thor?
3 to 5 millimeters a year.
Good.
Oh, yeah, you knew that.
Nick,
Oh, no, I don't know that one.
what is the C4 spreading rate?
I don't know the rate.
Okay, go ahead and look it up. Scott. What?
1 to 3 centimeters.
Very good. Okay, so coming back to Caleb. Caleb, what is superposition?
Superposition. Isn't that the one you gave me last time?
Yes.
All right. It's the layers on the bottom that do not change. Like they're on the bottom.
Nope.
Oh my God.
Layers at the bottom, they're generally
The layers at the bottom are on the
bottom.
They're generally the oldest.
Layers on the bottom of the
I
oldest.
know, I got the freaking notes right here.
You're supposed to learn it while I was waiting.
Oh, I mean, I was learning all the rest of them. I hope I was like, call me, call. No, somebody else. I said,
Okay,
all right, let me study your number.
uniformitarianism. Jesse? Very good. Braden, we said original horizontality, right?
The rock layers go up horizontally.
They start out flat. Yeah, good. And then Hannah, what did I ask you? Erosion rate?
No, you asked me like.
Oh, wait, why did I put your name there? You answered. Okay. Anyway, good enough. Halo. Superposition.
Layers on the bottom that are the oldest.
Are the oldest, right? So layers on top. Layers on top.
Every time's a charm, ain't it? Yeah, they're bottom.
What about layers on top?
They're the youngest.
Very good.
Ooh, bonus.
Very good.
Yeah.
Bonus for getting that right on the fourth try, yeah. All right.
I mean, you can't copy. It's not like
Okay, so we just basically reviewed all this. We're gonna get into more continental drift. I know we covered that a little bit, and then radioactive decay, uniformitarianism, we know, that we know, see this and that times. Okay, so we went from 10,000 years to 5 to 6 million years for age of the Earth, just based on measuring the rates of erosion and the depth of the Grand Canyon. There's lots of other places to measure erosion. It's not just Grand Canyon, but that's an easy one to identify. We talked about how the tectonic plates and the continents used to be together, a bit of a nice puzzle, especially South America and Africa. And the reason they're not together anymore is as a result of seafloor spreading at a rate of 1 to 3 centimeters per year, basically about the speed of your fingernail growth. And here's some more evidence of where the fossils line up. And of course, time will affect that a bit, but they have particular ranges, and so more evidence that the continents were once.
How the continents might plow through the oceans.
We already saw this, right?
Yeah. He caught his eye.
Can we see this one?
No.
Okay. Yeah, I tried to get it before and I couldn't for some reason, but I got it now. So this is the guy who first thought of the idea of continents were once together.
A meteorologist named Alfred Wegener was browsing through some books when something caught his eye. A list of identical plant and animal fossils that had been found on opposite sides of the Atlantic Ocean. Wegener was intrigued. How could the same species have gotten from one part of the world to another? He examined the eastern coast of South America and the western coast of Africa, and was struck how the shapes of the two coastlines might fit together. The more he looked, the more links he found. Species of land mammals in East Africa also inhabited the island of Madagascar. How did that happen? Did the animals evolve in both places at once? Or did they somehow cross from one land to the other, swimming hundreds of miles across the Indian Ocean? And then Wegener saw it all clearly. He realized that all the continents in the world had once formed a giant single landmass that he called Pangaea, from the Greek Pangaea, meaning all earth. It was in Pangaea that the plants and animals found on opposite sides of the world had once shared the same home. Then, over hundreds of millions of years, Pangaea had split apart, and its jigsaw pieces had drifted to their present locations. Wegener called his theory continental drift. Wegener wasn't the first scientist to speculate that the Earth had once been dominated by a supercontinent, but he was the first to pull together all the evidence and make a strong case for it. Unfortunately, his theories weren't very receptive. There was no mechanism to explain how the continents might fall through the oceans.
Mr. Tyler?
Continental drift was just too incredible to believe.
Sure.
As a result, his discovery was largely ignored.
402. Okay. You bet. Bye. Okay. So pretty interesting how they've been changing. Now,
That's right, we did get for it.
say what?
The video.
Yeah.
We got messages.
So we can actually measure, let me zoom in on this for a second. We can measure the distance between South America and Africa and, yeah, and divide that by the rate of seafloor spread, and we get 200 million years. So they've actually contracted with satellites, and that's how they know that the rate at which they're spreading is 3 to 5 centimeters per year. So it seems slow, and it really is, and that's why it takes 200 million years to for a continent to move across the ocean. All right, now we talked about magnetic poles.
Yeah.
Some of you say yes. Okay, what do we learn? What are we talking about with magnetic poles?
Every so often, well, it's not very often, the poles are flipped, and it takes about 100,000 years for the process to start.
Yeah. So if my hand is planet Earth, yes, this it's a spinning top, but it's spinning on the side. You're no, you asked what it was. I told you what it was.
Will it constantly go that speed?
No. It is not able to maintain the same rate of speed. It slows down because there is friction from the air and from touching the glass inside.
Gravity.
What if it wasn't touching the glass?
Then it would stay up.
Oh,
The glass holds it in place.
that's pretty cool.
I agree. That's why I bought it.
How much was
I remember I got it like 10 years ago.
it? Did you have to pay taxes?
It is not a magnet, but when you correct yourself, yes, it is. It does have to do with magnets. So there's a magnet inside here and of course in here, and they repel each other. And when they stop, the black part droops lower.
I had a chance to.
Have you seen the Levitron that they sell on ThinkGeek.com?
Well, it's not.
It's not black. What? It's not black in the phone.
No, it isn't.
Or should I say white faces up? Either way, I should read it.
Yeah.
Okay, so, okay, guys, I know you ain't taking no notes when your device is waving back and forth, really.
Look, magnetic field.
Okay, so explain why you're going like this.
It's easier to type.
Full of what?
Easier.
All right, so magnetic poles, here's the magnetic pole, right here. Here's planet Earth, here's north, middle finger north, thumb south. Okay, every 100,000 years, it's actually 100,000 between 100,000 and a million, the magnetic pole will flip. The Earth stays the same direction, but the magnet inside the Earth switches direction. So north will be south and south will be north. This is still north, but all the magnets are pointing this way instead of up. Okay, so that happens every 100,000, well, 100,000 to a million years. And it's actually been 750,000 years since the last one. Yeah.
Is it true every 20 years that we have a bad snowstorm?
Probably.
Because it happened 1953 to 1954. Those 2 years, they had a lot of snow. And then 73 to 74, they had a lot of snow. And then now they said 2013, 2014 was supposed to get a lot. We didn't get very much. So everybody's saying this year.
We'll see. It'll be exciting.
No, it's really not, because
It depends on wherever it is though, because there was a few years ago that there was a really, really bad one up in Kentucky that shut the whole city down for like just 3 weeks.
John put one so that it froze over the foot of snow so you could walk outside.
Yeah. All right, so 100,000 to a million years for the magnetic poles to flip. Like I said before, 750 years since the last one. When we measure the distance between the continents and we look at the space and we look at how often it spreads, we have two evidences that the Earth is at least 2 million years or 200 million years old. I should have had this one before that one, but let me show you. So 200 million years based on evidence of continental drift and magnetic pole flip. So as the continents are spreading apart, they start out here and they start spreading apart, and magma is coming up and forming new rock. When that new rock forms, the iron inside the rock aligns itself with the magnetic pole. So, all the little pieces of iron will be pointing north when the magnetic pole's north, and all the south ends will be pointing south. So north, south, north, south, north, south, and working our way out east. And we can come up with that time frame. So these spread, magma comes up, hardens, and aligns itself with the magnetic north. And what's interesting is the same thing happens with clay when you put it in a kiln. So they've been able to find pottery from a long time ago, and they've been able to measure or tell when the poles face a different direction, or when they were different than they are. Magnetic north moves around a little bit. Anybody who's a sailor knows that. And so magnetic north isn't always true north, so they have to be careful with that. You have to know where you're going. Okay. Okay, so everybody write down some sort of definition for radioactive decay. What is radioactive decay? And that is not the best question. Write down. Type it out on your device or write it on your paper. What is radioactive decay or radioactive decay? We also call it radioactive dating.
It's
Is that what we got?
It's always hard to get, that's always. That flash game.
And then it says the flash isn't even on.
Yeah?
No, notice that thing.
All right, so you probably have some sort of definition written down now. So go ahead and talk to your table and see if you guys have the same definition for radioactive decay.
Yeah, you got it all.
That's not a definition. No.
So what's the definition?
That's what I want you to try and figure out.
Radioactive. It has to do something about it.
Already did it.
Or like a banana. Apple, I eat banana.
Smaller than half-life, more unstable.
It's processed, but
See, I don't remember it.
whenever the radioactive isotopes break down until
Yeah,
it's
it sounds
stable.
like, isn't it smaller than half-life and more unstable?
No.
Okay, who thinks they have an answer that they didn't Google? Yes.
Radioactive decay is when unstable radioactive isotopes break down until they're stable.
Okay, can you turn that into English for us?
Yeah.
Whenever a material breaks down by like half-life because it's unstable and radioactive until it is no longer unstable and radioactive.
Okay, what do you guys know about uranium?
Extremely radioactive.
Okay, it's a radioactive element. Why is uranium bad?
Because it's radioactive.
Because it's radioactive, and why is that bad?
Because radiation is unstable.
Well, radiation is actually really small particles. Sometimes they're alpha particles, sometimes they're beta particles, and sometimes they're gamma rays. And these particles can go through really, really small things, really, let's put it this way. Gamma rays can go through 6 feet of lead without any problem. Okay? Alpha particles can go through a couple inches. No, actually, they can't go through lead. They can go through paper and through your skin. Okay? They're really, really small, and when they get in there, they can do damage. And so that's why radioactive is bad. And what they do is they damage your DNA and cause your cells to mess up, to not function correctly. And cancer can be one of the results of this radioactive interference in your DNA. And what cancer is when your cells don't ever die. They grow and they grow and they grow and they multiply and grow and multiply, and that's where the tumor is. It's a big collection of cancer cells. And if your cells never die, they cause problems. Anyway, so as Thor said, radioactive decay is when you have something like uranium. Radioactive decay means that the uranium nucleus, or the nucleus of the atom, breaks apart. Okay? How do we know what an atom is? How do we know uranium is uranium?
The smallest unit of
How the chemical makeup?
That's the number of protons.
By the number of protons. So uranium has 92 protons. How many protons does lead have? Look in the back of the Earth Science Building. Look up that.
Like, 82.
So the atomic symbol for lead is Pb.
Peanut butter.
What's the atomic number of lead?
82.
82? Are you sure?
Yeah,
You're right.
it's
Okay, 82. So it's 82. So what happens, uranium, because it's radioactive, these nucleus will break up and 10 of the protons will go this way and the other 82, well, so that would be neon, right? The other 82 are lead. And this is the radioactive decay. These parts break apart and you have radiation coming off that. Okay, so radioactive decay is the rotting of that nucleus. And the nucleus of different elements have a particular time it takes for them to rot. And it's called a half-life. Half-life is the time it takes for half of something to disappear or to change into another form. Okay? So let's take this piece of paper, for example. Let's say this piece of paper has a half-life of 20 seconds. After 20 seconds, half of this paper has become, we'll say carbon dioxide this way. It's become carbon dioxide, so that means I still have half left, yeah?
Yeah.
Okay, so half of it's become carbon dioxide, half of it's still paper. So after 20 more seconds, how much paper, don't answer out loud, how much paper will I have left? Don't answer out loud. Think about it for a second. After 20 more seconds, how much paper will I have left? Do you have an answer?
Yeah.
Okay, you have an answer. No. Okay, think. You have to have an answer. No help yet. Think to yourself. After 20 seconds, half the paper is gone and it's become carbon dioxide. The other half is still here. So what happens after 20 more seconds? You have an answer?
It's gone.
You don't have an answer. You have an answer. Okay. Who doesn't have an answer yet? Okay. Good. Now talk to your table and see what your answers are. What's going to happen after 20 more seconds? Okay. So let's ask Scott. Scott, what's going to happen after 20 more seconds? Half the sheet will be gone. Okay. Who agrees with that? Okay. All right. And you're right. Half of what's left will be gone. So 20 more seconds. There's only half left, which was a quarter of the original, right? So that's what happens with radioactive decay or half-life. There's a time limit for different objects where they decay and become something else. And that's how we're able to figure out how old things are, because we can measure the amount of uranium that's still in it or carbon that's still in it and determine how old it is based on that. You have a question?
No.
Oh, I missed.
That thing's already down like to the 30-second whatever.
This?
Yeah. Like, no, I mean like by the time that it has gone by, actually if you're going by 30 seconds, it'd be down like 32.
And that's right. And so 20 more seconds, how much will be left? Right now I've got a quarter. 8. That's right, 16. 30 seconds.
You're not going to have
64,
128. 256.
Yeah, 256, and 512, and so on. So then after, let's see, so what was it? Half, 4, 8, 16, 30 seconds, 64, 128, 256, 512, and that's where I stopped. So that would be 7 half-lives. So how many seconds would it take to get to this point?
140.
Yeah, seven
How'd
times,
you do that math in your hand like that?
seven times 20.
You know, it's cool though, something.
Hey, what's 7 times 2? That is 0. Yeah, so 7 times 20, that's how you get, so you take the number of half-lives, you multiply.
Please straighten your tie.
Oh, I thought the number of half-lives.
Sorry, I didn't know it was 15.
Yeah, I am smart.
Thanks for helping me out with that. Whoops.
The ties.
Like, you not think it's smart?
Okay, so let's try this again. Yes, yes, yes. It didn't really split, they blew it apart. Yeah, so when they blow an atom apart, you have subatomic particles. Sub means lower than or smaller than, right? So subatomic particles, you have atoms, or not atoms, but electrons, protons, protons. So. Hey, Caleb, thank you. All right, so.
I didn't do anything.
I know, good job. All right, so let's say it takes me 2 seconds to walk halfway between here and the edge of Andrew's table right there. Okay?
2 seconds?
What? 2 seconds. It takes me 2 seconds to go half the distance. So my half-life for walking from here to the table is 2 seconds. So after 2 seconds, 1,000, 2 1,000, I'm halfway. Where am I gonna be after 2 more seconds?
After just
3/4 of the way there.
What?
At this table.
Let's see. 1,000, 2 1,000.
You only took 1 step.
It took me 2 seconds to walk that far, because I'm going half the distance each time, right?
All right, so 1 more step, and then you're good.
No.
So 2 seconds.
1,000, 2 1,000.
By halfway.
A half-life is always half of what's left.
By halfway, they'll never make it to the desk.
Less
Ever. They'll never make it to the desk.
You'll never make it.
Molecularly close, but never make it to the
Yeah,
desk.
I mean, I guess I can reach out and touch it, but officially I'll never make it there.
But if you're touching it, then you're there.
But I can reach out and touch it, but my people never do. Remember this? Half-life of 20 seconds?
Oh, yeah.
Okay, so how much is going to be left after 20 seconds?
Yeah.
Right. How much is left after 20 seconds? Same thing here.
Oh, yeah, I got it.
Each.
Gosh, I got this.
All right, so there's a couple numbers you're gonna need to know. I'm only gonna make you know 2 different elements and their half-life. First of all, radioactive dating. Over time, radioactive elements can decay to form different elements. That's because they're losing protons. Uranium-238 is one of the ones you need to know. Uranium-238 has a half-life of 4.5 billion years. What does uranium-238 become? Lead-206. You need to know that. So uranium-238 becomes lead-206. I suppose if I were dating somebody really hot, that can be radioactive dating, right?
Radioactive.
Oh, yeah, maybe something like that.
So radioactive, or uranium-238 becomes what? Lead-206. Okay, and it has a half-life of how long? Okay, good. So after 4.5 billion years, how much uranium is going to be left?
None.
Half. After 4.5 more years, 4 billion more years, how much is going to be left?
Quarter.
Quarter, very good.
Then at 8, then at 16, then at 30 seconds, then at 64, then at 28.
Okay, everybody got the 238? Okay, so the next one we need, the only other one we need is carbon-14. And carbon-14 becomes nitrogen-14.
Hydrogen?
Yeah, it's supposed to be nitrogen. The image I got off the out of one of my books, they had a typo in the book. So that should be nitrogen, not hydrogen. So carbon-14 becomes nitrogen-14.
That's awkward, because that's the typo in every single book.
Yeah. There's typos in every book. Oh,
You think so?
oh, guaranteed. Every book I've read, I found one.
Alright.
You know,
read books.
well, there you go.
I don't read books.
Okay, so
You read books?
you need this half-life. Carbon-14 turns into nitrogen. It takes 5,730 years.
12.3 years.
Yep, hydrogen-3 becomes helium, and that takes 12.3 years.
Oh, it's good. Half the life. Its full life would be 24.
There's no such thing.
6.
There's no such thing.
There's no such thing as it.
It's funny because you get it, but you keep contradicting yourself. You forget that you get it.
I mean, I get it, but I mean, like.
That's what I just said.
I understand.
That's what I said. But then you don't get it like a second later.
He's Dory providing.
Yeah. Okay, so now as you can see here, there's a bunch of different ones, and this isn't even half of them. There's a lot more. And we can use those different isotopes to measure the age of different objects. Let's say I find a skull, and we do carbon dating, and we determine that the skull is 11,000 years old. How many half-lives have passed? Okay, 5,730. How many half-lives have passed if the skull is 11,000 years old?
2.
About 2. Very good. Okay, so how much carbon-14 is left after 2 half-lives?
8.
An 8. Very good.
I would get 2.
Actually, no, an 8 is 3. Yeah, it's 4. Okay, so what's the half-life of uranium-238?
Radium 238.
4.5 billion years.
4.5 billion.
Yeah.
And then
carbon-14.
No.
Now, that skull we found, which would be better to use to date the skull? Carbon or uranium?
Carbon.
Okay, so I want you to write down your answer and explain why. Which would be better, carbon-14 or uranium to date the age of a skull? Okay. Which would be better to date the age of a skull, carbon-14 or uranium-238? And explain why. Come on, write it down. Let me see some answers.
Mark, now do I show you all my notes?
Yeah, man. We're almost out of here, aren't we?
Yeah.
It'll back 1 minute.
Yeah, I gotta go.
All right, we'll have to finish that. All right, good job today, guys. Don't be drugs, reaching everyone down the hill. And I need notes approved from Hannah, Caleb, Scott, Caitlin, Thor, Jesse, Aaron, and Andrew. You were on your phone a lot for just that little bit ago.
How can you say that?
You need the age. That's why it's carbon and uranium though, too.
All right, I'll get that.
One have to be ready.
Radioactive, radioactive. This is the only time this year that I've been happy that I'm taking different sciences.
I've been happy.
Because I actually know something about one thing.
I've been happy to do science classes.
What's the other science class you're taking?
Ag science.
That's a specialized thing, it doesn't count.
School classes. Thursday night, I got sick and